Hello guys, let's welcome to our channel Just Genius. As the previous video, our previous video takes more time and more long, so I made this video to solve more examples on the time complexity, that is analyzing loops. So just once you can recall what we have discussed in the previous videos. So we have discussed this order. This order is very important. Okay. So just see that order. Later we can come to that order. Why did I discuss about this order? Why did I paste this one? So first we will discuss about this example now. Okay. Okay. I hope that you can able to see this example. Okay. How to solve this example? So if you don't know how to solve, just take this iteration, just iterate this loop. So substitute any value of the n and until the k value, until some put the m value or k value, then until that iterate that loop and you will get that one condition, and that condition must be here what it is equal to n. So equal to n, you will get answer. Okay, so I will show how to iterate that one. First, before iterations, first I will show iteration I. Here we will get values, so for iteration, for 1, for I equal to 1, I will get 1. For I equals 2, I will get I value will be become 1, so I will get 1 plus 10. Okay, understand? 1 plus 10. So for I equal to 3, I will get 1 plus 2 into 10. Okay, how did I get 2 into 10? You are understanding? I hope that you are understanding. Similarly, if I substitute I equal to m, I will get 1 plus m minus 1 into 10. Okay, so previous value minus 1 into 10. So if you observe these conditions, we got like that only. Previous value minus 1 into 10, like that only we will get. So directly you can put this value equals to, I told you, put this value equals to n. Why? Because when you observe the question, I is equal to the I is equal to n. So put the value directly. Okay, I is equal to n. So put the value equal to the n and solve that problem. Okay, so I will show how to solve now. So just move this one down. Wait one second. So I have moved this down. So we can solve here. So n equals to 1 plus 10 into m minus 1. Okay, n equal to 1 plus 10m minus 10. N equals to, from this one we can draw the value of m. Okay, understand? Draw the value of m. Why to draw the value of n? Means to find the time complexity, it is very easy to draw the value of m. From this one we can get m equal to n minus 1 divided by 10 plus 1. Understand? How did I get this value? M equal to n minus 1 divided by 10 plus 1. Okay, from this one, if I take this is as our time complexity, now TC, time complexity equal to, first ignore the constant must be ignored, next 10 must be ignored, next minus 1 must be ignored. So big O of n, answer is big O of n. Okay, understand? How did I get? First equate to n equal to what you have got the equation. Next, from that value you can get the value of m. From that m you can substitute, you can find the time complexity like this. Okay, so if you take another example, so if you take this example, so here it is given I equal to, first you see how much the I is iterating. Suppose I equal to I plus 1, you have some I equal to I plus 10, you have some. For here I equal to I star into 10, here going to multiplication, here we are going to multiply. First start with iterations. For I equal to 1, for I equal to 1, the answer will be 1 only, that means it will come 10 power 0. I equals to 2, answer will be 10 power 1. Okay, understand? I equal to 2, I equal to 3, it is not 10 power, it is multiplication, you know. For I equal to 1, it becomes 1. For I equal to 2, it becomes 1 star into 10. For I equal to 3, it becomes 10 star into 10, because for every value I is going to update, change the value of the I. For every value I is going to update, so the I value is going to update. For I equal to 4, I value will become 100 into 10. So similarly, if you take for I equal to k, I value will become 10k minus 1. Because why did you get 10k minus 1? Observe the orders very carefully, so you cannot able to see all in once. This is very small screen. I hope that you are able to see now. So from here you will write 1 as 10 power 0. Okay, from this one, this is 2, you are getting only power 1 here. This is 3, you are getting power 10 square. This is 10 cube. 4, for you are getting 10 cube. Similarly, for I equal to k, you are getting 10 power k minus 1. Okay, if you don't understand, please watch this video again and again, neatly and claritily you can understand. 10 power k. So from the question you can see that, from the question, from this loop, I is equals to n. So substitute that value to n and get the answer, and get the proper answer. So from this one you can substitute. What did you get? 10 power k minus 1 equals to n. From this one get the value of k. To get the value of the k, take both side logarithm. Logarithmic, if you take log 10 to log n, so log 10 to the base 10, here base 10. So log 10 to the base 10 is 1, you know, where k minus 1, equal to log n. Okay, where k equal to 1 plus log n. So if you find the time complexity, Tc equals to, ignore the constants. Now answer is big O of log n. Big O of log n. Okay, understand how did I get this value? First if they give loops like this to you, first take the first take this loop and substitute some values, iterate this loop and check this condition, previous condition and till now condition, and put for something value of the k. Until that value of the k, what will the loop will become? You check that condition and equal to n. So in the question it is given I greater than, less than or equal to n, so I substituted it is equal to n. So you have got answer is time complexity equal to big O of log n. Okay, so why did I teach this order? Why you have to remember this order? And initially while starting the video I had told you to remember just this order, because we always calculate the time complexity in upper bound. Here this is an upper bound. So if you look into these questions, for example third example, we look into what we got answer. We got answer big O of n. So in the place of n we can substitute log n, big O of log n, because where we can check log n, where is the log n? So log n is in here. Log n is here. This becomes lower bounds. We cannot substitute log n. So answer is wrong. So we cannot substitute log n here. So we cannot substitute. Erase it. So can we substitute n square? So one check in that order. Is the n square belongs to upper bound running time or not? So n square. Here is the n square. N square is belongs to upper bound. So we can substitute n square in that value, because all the values which are belongs to the upper bound, you can substitute any value, because time complexity we are going to calculate in the big O notation, because it takes upper bound calculation. I have written very clear example, very clear statements here. You can study these statements very carefully. You can write. So if you study these statements clarity, you can understand. Also, if you take the fourth example, what we got answer? Big O of log n. So we can substitute big O of 1. Why cannot? Because when you look into the statement, log n belongs to this one. Here log n belongs to. So when you look into this statement, log n is here. So 1 is here. It is belongs to lower bounds. So we can substitute 1. Okay, understand why I am going to substitute 1, why I am going to substitute log n, why I am going to why I am going to substitute n square. You have to identify these terms very carefully and understand this one. Okay, with this we have completed 2 examples on this big O notation. In next video we will solve some more examples on the big O notation. Okay, so when you look into first, okay, suppose one thing to you, main thing, just brief in the brief thing we can discuss in 1 minute. Suppose if a loop is given to you, just iterate that loop until some value of the k condition. For that value of the k condition, when you until that loop, you can substitute some values of that k and iterate. For every iteration, the iteration value of the I can be changes. Until the changes the I, also the k value can be updated. From the updated value of the k can be equal to I equal to n, such that I equal to n means you substitute the value of that what you got the equation equal to n. From that one you get the value of the k and get the value of the k in terms of n. From that one you calculate the time complexity. I hope that you are understanding my words are clearly. If you don't understand, please listen these words very carefully and pause this video and think on. So if you don't understand this, you cannot understand, you cannot solve the time complexity problems. Okay, thank you.